Now, here we're going to start talking about security practices or the best security practices in Kubernetes. It is always advisable to follow some of the best practices at security level because in the case of Kubernetes, if some of the applications or containers are compromised, you can have issues, security issues in the whole organization. And one of the easiest ways to protect the Kubernetes security is using secrets. So this is one of the best practices, especially if you don't want to store sensitive data such as passwords, SSH keys, or tokens in a place that's accessible. So the use of secrets allows you to control how the sensitive data is used, and it significantly reduces the risk of exposure of sensitive data to unauthorized users. Another way to make sure that your security is on spot is to use firewall ports. And the firewall ports are a security practice that is very frequently used since it is not advisable to expose a port that doesn't need to be exposed. So for that reason, it is the best to define the port's exposure policies to prevent that from happening. The first thing you should do is to check for the existence of some interface or to define an IP to link the service. For example, the localhost interface. Some processes are opening so many ports on all interfaces that it is better for them to have a public access firewall. This is because they allow purely confidential information and direct access to a set of computers. For that reason, a public firewall, which is the most secure, should be implemented in that cases. Another very good option is to restrict the Docker pull image command. So Docker is a resource that sometimes could be a little uncontrolled just because it is so simple to use. So everyone who accesses the Kubernetes API or the Docker container can obtain an image from them if they want. That access could generate traffic from infected images and cause serious security problems to your Kubernetes distribution. And trust me, this is quite a common practice because recently many clusters have also become a network for Bitcoin miners. So there is actually a plugin called Image Privacy plugin that can, if not solve completely, can significantly reduce and restrict the image access, and it connects directly with the Docker API. This plugin adds a series of strict security rules that reflect a black and white list of images that can be exposed. Another way is to use an image privacy webhook with admission controller. This would intercept all images that are extracted and take care of the security, just like the plugin that I already mentioned. You should always note the authentication and the authorization mode that your system is using. This can be done by verifying the parameters, where you can also check if the authentication is configured anonymously. It's important to know that this configuration will not affect the kubelet authorization mode since it exposes an API to its own from where it executes commands that kubelet can completely ignore. So when we talk about giving permissions in a Kubernetes cluster, we'll have to talk about the role-based access control, which manages the security policies for users, groups, or pods. It is implemented in a stable way in the latest version of Kubernetes, and you can actually define those specific rules by using the following code. So you need to simply add the API version of the authentication, the kind, which is the cluster role, and then the metadata and the rules, the security rules that you would like to apply to your project. And finally, it is important to have a good management of your resources and limits. It is important to manage the resources and limits that you are going to assign to your applications when creating container in Kubernetes infrastructure, especially in production. This is quite important at a security level because a single container can generate a denial of service when sharing a host with other containers. So in the generation of the pod, we can easily control it through the requests and the limits section in the deployment execution file, a file that is quite similar to this one. So let's look at some of the specific security feature components that are built in Kubernetes. This is because Kubernetes already offers native security features to protect against some of the threats that I already described and mitigate the potential impact of those risks. So some of the main safety features include the role-based access control, because Kubernetes allows administrators to define the roles and the cluster roles that specify which users can access which resources and in which namespace or entire cluster. In this way, the role-based access control provides a way to regulate the access to the resources. Another quite good safety feature is the pod security policies and the network policies. So administrators can configure pod security policies and network policies which will pretty much place restriction on how containers and pods can behave. For example, pod security policies can be used very well to prevent containers from running as root users. On the other side, the network policies, for example, can easily restrict the communication between the different pods. And finally, another very nice built-in feature is the network encryption. So the standard encryption that is used in Kubernetes is the TLS encryption, and this is set by default and provides additional protection for encrypting the network traffic. So all those three security features of Kubernetes provide a very good defense against certain types of attacks, but of course they do not cover all threats. And so I also provide you a list with threats from which Kubernetes doesn't offer native protection. And the first one is the malicious code or incorrect settings inside containers or container images. For example, a third-party container scanning tool should be used in order to scan the container because Kubernetes doesn't have built-in feature for that. Another one is security vulnerabilities in the host operating system. And because Kubernetes pretty much doesn't control the operating system in which it runs, you should make sure that you have other tools to control that. Some Kubernetes distributions like OpenShift integrate security solutions like SE Linux in order to protect the Linux kernel, but this is not a root feature of Kubernetes itself. Kubernetes also doesn't offer support for container runtime vulnerabilities finding because Kubernetes has no way of alerting if a vulnerability exists in the runtime or if an attacker is trying to exploit vulnerability at the time of execution. Another risk is the Kubernetes API abuse because Kubernetes pretty much doesn't do anything to detect or respond to API abuse beyond the security policy settings that you can define. And finally, it doesn't have management tools for finding vulnerabilities or configuration errors. This is because Kubernetes cannot guarantee that management tools such as the kubectl are free from security issues. So normally a secret is everything that nobody else in the cluster should know, neither the rest of the application nor the users that access the cluster. For example, a password from certificate store, an API key, and so on. So let's say that someone discharges those resources along with certain permissions. From there, it is the application that requests those secrets from Kubernetes by presenting the information that authorizes them to consume those resources. So authorization management is done through what is also known as role-based access control. This means that the application can access certain types of resources only if you have certain role. So you can see that using secrets will pretty much allow you to control how sensitive data is used and significantly reduce the risk of exposure of sensitive data to unauthorized users. This information is often posted in the pod specification or in the container images, and so a secret can be generated both by the user or by the application. So here you can see the basic model for how you can store secrets in the cluster. You can see that the pod and the secret are into two separate places, and once you have both of those, you can go to the node and from there to the database. Other interesting facts about the secrets are that the secrets are pretty much objects with namespaces, and so they exist in the context of a namespace. You can normally access them through a volume or environmental variable from the container that is running the pod. So I would say let's see some examples on how you can create a secret with username and password for a Postgres database. So let's open a terminal and make sure that Kubernetes is running in the background. Okay, and now let's create some files. Okay, so let's do echo -n user. Okay, and we're gonna save that into the user.txt. Okay, now let's create a password. So let's do echo -n password, and then we will save that into a new file called password.txt. Okay, so let's now create a Kubernetes secret from both of those files. Now let's do kubectl. Okay, and actually before executing the command, make sure that you also run Kubernetes. So let's create a new terminal, and you can do that with Minikube that you already installed. So let's do Minikube start --wait equals to false. Okay, so you can see that now your Minikube distribution is starting, and so now you can see that Minikube is running. So let's go back to the terminal and let's do Minikube or kubectl create secret, and then this will be generic secret. Okay, db -user -password -form -file equals user.txt let's do here from instead of form, and let's now use the other file. So from file equals password.txt. Okay, so let's hit enter now, and you can see that here this already exists for me, but I guess for you this was a successful creation. I will just edit the name a little bit, so I actually create another secret file since I already have this one. Let's do password s. Okay, and you can see that the secret has been successfully created into my device. So if I do now kubectl get secrets, you can see that I have that secret that I just created right here, that was created 15 seconds ago, as you can see. And on data, you can see too, since we use two files. So if you want to see the definition of that file, you can do kubectl describe secret db -user -password -s in my case. Okay, so you can see that here this secret has two files. One is 8 bytes and the other one is 4 bytes, and both of those are text files, the password and the user that we just used. So once the secret is created, there are pretty much two ways to consume the secret. You can mount them as a volume, or we can access them from the pod. So we're going to do the second one, and in order to do that, we will need to create a YAML file with all the creation parameters. So here is the deployment pod YAML file, and it has a pretty known structure. So what we're doing here is we're defining the kind, we're defining the API version, which is version 1, the name, the app that we want to use. Okay, and also we're defining, of course, the specs, the path within the image, and also we're defining, as you can see, the files that we want to use. So we use username txt and the password txt files. Okay, so you can take that file from here and just type the information that you can see, or I will also provide this file, of course, as a source code in this section, so you can use it and see how it works. What you simply need to do is to go to the directory where you have this file. Okay, so for example, I have it right here. Here it is, deployment pod YAML. Okay, and then you just need to run the command kubectl apply -f deployment pod.yaml. Okay, so let's hit that, and you can see that now we have the deployment app that has been deployed into Kubernetes. So the app is being created. So if you go to another terminal and write minikube dashboard, you'll actually be able to open the Kubernetes dashboard and you will see your Postgres deployment app right here. And you can see that you're using the image Postgres, and also your app is using the label Postgres. Okay, so let's go back, and here you can see the deployments, the jobs, basically everything you need to see from your Kubernetes. So I will keep that dashboard, and I will go again to the terminal, and I will actually run another file that will be called secretpod.yaml. Let me show it to you. Okay, so this is another file which will pretty much run Alpine image and will make sure that our secrets are within a secret volume, which will help them not to get accidentally leaked. Okay, so again, I'll provide you this file into our source, and let's actually run it. So let's do kubectl create -f secret pod.yaml. Okay, so let's hit enter right here, and you can see that now we created a new pod, right? So before we were creating distribution, but now we create a new pod and we applied our secrets there. Now if I go here and I go up, you'll see that we have our pod up and running. You can see that the light is in green, so it is properly running into our Kubernetes cluster. So once this pod is available, you can actually list all secrets available if they are a regular data. So if I do kubectl exec-it secret vol pod, and you can do here ls etc secret volume, okay, you'll be able to see the passwords from which and the files from which you're creating the password and the user. So this is how, guys, you can create secrets, but let's see some additional strategies that we can follow in order to manage the risks of putting your application in Kubernetes in danger when you want to run it into production. So you should always try to integrate the security from the early stages of the development. With Kubernetes, it is necessary to integrate the security at each stage of the software development process. It is a mistake to leave the security settings for the last step, where it might be pretty much too late. You should also consider the commercial platform of Kubernetes. So when you participate into the Kubernetes trading platform, the most important benefit you get is the rapid structural responses from the Kubernetes development team for any threat or problem that you face. You will be updated quickly for any vulnerability, and also you will have the most latest security policies implemented. Even though this version might be paid, if you're running a business on long term, this might save you more than it would actually take from you. And finally, don't trust to old security tools or practices. This is because, just like you, the attackers update faster than the software. So some of the technologies that are outdated might not work with the new attacker techniques. You should not assume that your conventional security tools will always protect you. Many open source tools evaluate Kubernetes clusters or perform penetration tests on the clusters and the nodes. It is always necessary to keep your software updated and patched. So some of the most common security risks are normally appearing, for example, in the containers, because they can contain malicious code that was included in your container image. They can also be subject of misconfiguration and allow attackers to gain unauthorized access under certain conditions. Also keep an eye on your host operating systems, because it is quite common to find vulnerabilities in malicious code within the operating system installed on the Kubernetes node. Kubernetes also supports a variety of container runtimes. All of them can contain vulnerabilities that allow attackers to control individual containers, escalate attacks from container to container, and even gain control on the Kubernetes environment. And finally, you should also know that Kubernetes always relies on internal networks to facilitate communication between nodes, pods, and containers. It also quite often exposes applications to public networks so that they can be accessed over the internet. Both network layers, internal and external, can always allow attackers to gain access to the cluster or escalate attacks from one part of the cluster to another. That said, thank you very much for watching this video, guys. It was a long one, but I'm sure that you learned quite a lot about the most common Kubernetes vulnerabilities and how to manage and create Kubernetes secrets. Thanks for watching, and I will see you in the next video.